video, we're going to look at 3 classroom activities that help children see with attributes. The yes or no game, the attribute train game, and the mystery block game. These are wonderful activities because they combine geometry with logic and communication. Let's start with the yes or no game. In this game, one person thinks of a block. The other person asks yes or no questions to try to identify it. Let's say I have a block in mind, and a person starts by asking, is the block a quadrilateral? And let's say I say no. Then we're going to remove all of our quadrilaterals from consideration. So all of our rectangles and all of our squares will get removed from the game, since we know the shape is not a quadrilateral. Next, someone may ask, is the shape small? And this time I say yes. So we're going to remove all of our large shapes from consideration. Our possibilities become even smaller now. The next question might be, is it a circle? And I would say no. So we're going to remove any remaining circles. Then someone asks, is it a triangle? And once again, I say no. So we remove these triangles. And finally, someone asks, is it blue? And I say yes. At this point, there's only one shape left, and it is the small blue hexagon. This game is great because it encourages students to ask strategic questions and think carefully about which attributes are most useful. Now let's look at the attribute train game. This is another classification game, and it involves making an attribute train using the attributes of color, size, and shape. Any block is selected and placed. Let's start with our large blue square. That block becomes the first block on the train. And we're going to make a 1 difference train. So the second block should be 1 attribute different from the first block. Then the third block should be 1 attribute different from the second block, and so on. For this game, players take turns adding a block to the train. Each time a player chooses a block and explains how it is different. So we start with this large blue square. The second block could be a small blue square, since the only way they differ is through size. After that, we could use a small red square, the only difference being color, and then maybe a small red triangle, the only difference being shape. We could then do a small red circle, once again, the only difference being shape, a small yellow circle being color, and we can keep going. Maybe now we want a large yellow circle, so we change the size. A large yellow rectangle, so we change the shape. A small yellow rectangle, so we once again change the size. A small blue rectangle, this time we change the color, and we can keep going. Each time, only 1 attribute changes. The train continues until all of the blocks have been used. This game helps students attend closely to attributes and describe change in a precise way. And while we did a 1 difference train, you could do a 2 difference train, where everything needs to be different in 2 aspects, or a 3 difference train, where they need to be different in all 3 of the aspects. Now, let's look at the mystery block game. In this activity, students identify the mystery attribute block or blocks using logic clues. So, the first clue that our instructor gives us for this particular puzzle is I am not red. So we will start by removing all of the reds, since we know our block is not red. The second clue, I am not a circle. So we will remove any remaining circles. The third clue from the instructor, I am not large. So we'll remove all of our large shapes. Next, I am blue. So we will remove anything that's not blue. I do not have obtuse angles. Our hexagon has obtuse angles, so we will remove that. And then the final clue is I do not have right angles. So that will remove my rectangle and my square. This leaves the small blue triangle. Let's do another one. I am not a quadrilateral. Not a quadrilateral means no squares and no rectangles. So we'll remove all of our squares and all of our rectangles from our valid list of objects. The second clue, I am large. So we'll remove all of our small shapes from our choices. Next, I am a hexagon or I am blue. A circle is not a hexagon or blue. This yellow triangle is not a hexagon or blue. Same thing with this red triangle and this yellow circle. Everything left is either a hexagon or blue. Our next clue, not yellow. So I'll remove the yellow. Next, I'm a polygon with equal sides. I'm going to remove this circle since it does not have any sides, and I'm left with these three shapes here. Finally, I am not a triangle, so I'll remove my triangle. So this one, we actually have two possible answers. It is either the red hexagon or the blue hexagon. We would need another clue to figure out which one of these it is, but we could also have the possibility that there is more than one answer. Let's do one more. I am red and large. And means it needs to be both of these. So we can go ahead and remove all of our blue and all of our yellow to start with, since we know it is red. And then we also know that it is large, since it is red and large. So we can remove all of our small red shapes. That leaves us only with the large red ones. Next, I am not a quadrilateral, so we'll remove any quadrilaterals. I do not have obtuse angles, so we'll remove the hexagon. Finally, I have more than 3 lines of symmetry. A triangle only has 3 lines of symmetry, and this has more. A circle has an infinite amount of lines of symmetry. So this points us to the large red circle. These games are powerful because they help children reason through possibilities, justify decisions, and use increasingly precise mathematical language. And as a future teacher, this is exactly what you want to notice. Not just whether students get the answer, but how they narrow down the possibilities. That reasoning is gold. You're doing important work by learning how these simple-looking activities support deep mathematical thinking.